Okay.
Okay.
Of course, then the Adam comes in.
Yeah.
Hi, Adam.
Evening. Evening. Sorry about
Hello.
the lateness. Oh, I do love you, John.
Yeah, I bet you do.
Oh,
So we've got
Hey,
the Adam Meakin, Betty Van Velsen, Paula, otherwise known as Bible Literalist, and Quantum Eraser.
yes.
No,
Get a
no
cookie.
Ranty, no Anthony.
Yeah. So listen, guys, we're going to go through the presentation, me and Nathan, and just hold back on any of your questions or comments. And then right after the presentation, you could go wild. I just don't want to get... Say again?
I'm not going wild.
You can go ahead with your comments. I know it's hard for people to do that. Just go on mute. I ask you this. I beg of you.
from now or when we go on broadcast?
Yeah, when we start, after we start. When I start the presentation, just chill out until after I'm done.
I shall wait until you're finished, my friend. No worries.
Thank you, sir.
Can you start it on the... Because we're recording, I don't want to give the game away for the people who actually do watch this little bit at the beginning. So, can you put it on the how did I phrase it? The stunning 3D animations.
Me?
Yeah, so when I transition across, I want it to start like that. It'll start with the pouring bottle, but when I transition to Skype, I just want it to look like you've got it now. That's perfect.
Is that perfect?
Yeah, just
Because I'm not.
Yeah, fine.
I'm not going to that. I'm not starting with that.
Okay,
You following?
then that's
I'm
fine.
gonna
Okay, yeah, fine. Okay, start on your presentation. I'll just jig something around and just not transition from the bottle. That's fine.
You sure? Because
Yeah,
I can pull it
no
up.
worries. That's fine.
and
That's
then-
fine.
Okay.
2 minutes and we'll start live.
Sweet.
I've got to be honest with you. I'm very excited, boys. You know, you've promised a lot.
Yes, we have.
And if I didn't know what a buggy you were,
Nah, it's just going to be too easy, man. This is just too easy. It's well done. It's sublime because of its simple elegance.
If you are watching this on the Nathan Oakley premiering stream, please share the show. One minute.
Hey, be careful. Be careful about Nathan's introduction, man. It's going to crack you guys up. So I would probably go on mute.
I wouldn't worry. I have your line muted.
build him up, John. Build him up.
Yeah, because it's good.
I know that we're starting. Right, everybody ready?
Go!
All good and muted.
Introducing the most technologically advanced, topographically accurate, pseudoscience Earth model the world has ever seen. A model capable of making advanced pseudoscience predictions about our world with stunning 3D animations and an easy-to-use globe comparison mechanism. Ladies and gentlemen, I introduce to you the Flat Earth Model. Welcome to BALLBUSTERS Live. I'm your host Nathan Oakley, and joining me this evening is the Adam Meakin, Betty Van Velsen, Paula, otherwise known as Bible Literalist, and Quantum Eraser. If you are new to this channel, be sure to subscribe and hit the bell notification icon to keep up to date. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a PayPal, Patreon, and crypto link in the info box below the video. Welcome to one and all. Hello, Ballbusters.
Good evening.
Hello, good evening.
Is that it?
Ahoy, ahoy. I knew I'd get stepped on by somebody.
I left a long enough pause. Did we get a hello for everybody? I think we did. So, in case you hadn't already gathered, we're going to be introducing the most glorious, fantastic, spectacular model of the flat Earth anybody has ever encountered. We're going to show you in depth how to use this amazing tool to make advanced pseudoscience predictions about the flat Earth. It's going to be glorious. Fasten your seatbelts.
That's a lot to live up to, man.
Sure is. And we are not messing around. We are not joking.
No, we are not.
Mate. I'm buzzing like a teenage girl waiting for a Take That album to come out, mate. So
you and me both. Right, well, if we can all contain ourselves, we're going to start off by John giving us the full presentation about what's going to be shown here. Are you ready, John? Quantum Eraser.
I'm ready.
Right, your screen's up, you're presented. Let's go.
Yeah, so before we get to the main event, I'd like to briefly touch on two stupefying phenomena that the ball-tard spinning space monkey cult apparently and inexplicably has all of a sudden gotten a case of the willful stupids with. And we've talked about this before. And I'm kind of shocked that they forget about this. You know, it's called vertical drop. You guys remember this from 2015. This is the quintessential tenet of your spinning ball religion. You got to have drop. Every point from a tangent from your feet drops. That is vertically drops away from you at 8 inches per mile squared. Did you guys forget about this? I mean, come on. You see this tangent line? You see this drop? Right? I can't believe you forgot about this. This is like a hockey player forgetting what ice is, or John Wayne forgetting what a horse is. I mean, come on, people. And the next one, the meaning of level and flat. Well, let me break it to you. Level equals flat. They're mutually inclusive. From Merriam-Webster. Level, to make a line or surface horizontal. Make flat or level. Level synonyms: even, flat, flush, plane. Level, flat, plane, even, smooth means having a surface without bends, curves, or irregularities. From dictionary.com, level, having no part higher than another, having a flat or even surface. Level, being in a plane parallel to the plane of the horizon. Horizontal. Level, to make a surface level, even or flat. From Cambridge. Level, not rising or falling or higher on one side, but even in all directions. Horizontal or flat. Something that is level with something else is at the same height. Level, to make a surface flat. I mean, why do I even have to provide citation for this? I don't know. I wish somebody would tell me. So, the flat Earth model predictions, right? That's what we need. We need to test this, correct? Number one, since the Earth is flat, we would expect to measure no vertical drop, i.e. flat or level, between 2 points, separated by 500 miles. Number two, since the Earth is flat, we would expect to measure no vertical drop, i.e. flat or level, between 2 points separated by 1,000 miles. It's just that simple. we are going to test this model. So, without further ado, on behalf of the Supreme Council and my highly esteemed and distinguished colleague who has been knighted, Sir Nathan Oakley, it is my honor and privilege to present the only model of the Earth that has seen the light of day over the past 4 years. Here it is. Brought to you by our Flat Earth friends over at Google Earth. Hashtag same team. They seem to have hidden it in plain sight. So I didn't bring you here for us to gawk at this. Remember, we have 2 predictions to test, right? One at 500 miles and one at 1,000 miles. So let's take the 500-mile measurement. We'll wing on over to the Med and jam with Mick and the Stones. What do we got here? Well, we have a 500-mile distance between the shore of Sicily and Libya. So let's take a look here. So everything's in plain sight. We're going to take an elevation of point D. And what do we got? We have 4 feet. So let's wing on over to Sicily. What do we have for an elevation in Sicily? Well, we have 4 feet. Now remember the definitions that I told you. Level, not rising or falling or higher on one side. Horizontal or flat. So this meets the definition, right? Let's take a wider view. We'll get an elevation profile. So, from the shore of Sicily, for 500 miles, as you can see, we have a 0.00 vertical drop. In fact, it's 508 miles. Validating the first prediction of our flat Earth model.
Whoa, whoa, whoa. You're revealing one of the extra technological advancements in this model there.
Oh, I did. Sorry about that. That's right. I revealed it.
We'll cover that later.
Now, since we've already validated the first prediction of our model, let's wing on over to the Gulf of Mexico for our 1,000-mile measurement.
Whoa, 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 whoa. Ah. You're revealing the advanced features again.
That's a little added feature.
Yeah, we'll cover these advanced features.
So at point A, this is southern Texas. So nothing is hidden. Point A, let's get an elevation here. I got 3 feet. Let's wing on over to southern Florida. See what Pet Detective's up to. Point B in southern Florida, we have an elevation of 3 feet. That matches our level and flat definition, not rising or falling or higher on one side, horizontal or flat. Go for a wider view. Get an elevation profile.
May I make my small interjection here, save me doing the advanced feature coverage later? So,
Sure.
Obviously, along the bottom line, we have a perfectly flat reference to the elevations, which John is dragging across as we speak. He's showing it with his mouse. Just wave your mouse so people can see what I'm talking about, John. There we go. It's referencing a flat surface. Now, one of the advanced services that's offered is that you can make a direct comparison between these two. So I don't know if you can just roll your line so that it's at the top, John, leaving the elevation profile on. If you can move the animation so that the line you've drawn is at the top of the frame of picture. So roll Google Earth with the down key.
I see what you want. Okay. Let's see what we got.
Other way.
Let's go to the other one.
There we go. Stop. That'll do. So you can see the comparison between the graphic, which is what the fundamentalist religious zealots believe they live on, versus the actual reference in the elevation profile at the bottom. Very useful tool to show what they think they have versus what's actually being measured and demonstrated and what it's referencing flat. A useful tool, but sorry to interrupt. Saves me doing it.
No, that's okay. So from the southern point in Texas, we're moving 1,000 miles. And as you can see on our trip, we have a 0.00 vertical drop. Each are 3 feet elevation. This matches our predictions for our flat Earth model, validating the model. It's just as simple as that. Now, the globetards' only port in the storm against our model is this claim. Elevation is measured from the center of the Earth. That's just code for gravity, right? They put gravity into everything. I think it's in their scrambled eggs in the morning, right? So that is every point along the surface of the Earth is equidistant from the center of the Earth. Our retort, A, from their alma mater wiki. Elevation is not to be confused with the distance from the center of the Earth. And B, how in the world can they make the claim when they live on in an ellipsoid? Make us a little bigger so you can see it. So we're going to cross here and quarter this thing. Now, can you tell me on this quarter what position or what points on the surface of this ellipsoid is equidistant from the center of the Earth? Let me give you the answer. 0. None. So this is cod swallow horse pucky. In conclusion, the Earth is not only obviously and observably flat locally, it matches the model's predictions perfectly over vast differences or over vast distances. Thanks for your ear. Have a nice day.
Excellent. Thank you very much indeed, John. Sorry about my interjections.
No worries.
So spread the word. Spread the word. That's it. That's your lot.
Any questions? Any concerns?
Nope. It's still the sticking point for them is they want to redefine level as parallel to the surface of a ball. That's the only thing they can do. So Google Earth has been a flat Earth map all this time by its own measurements. And they said, but the line is curved. We put it, well, they put an arc in it, but they have the same elevation the whole time. You went along that graph, that showed elevation over the course of that line. It never changed. But it looks curvy, therefore it must be a ball Earth. That's how bad it is in the chat.
There's no way out. And listen, I don't know how many times over the past 3.5 years, and a lot over the past 2 years, is initially, as soon as a flat earther arrives, what do you hear? Show us your model, right? Immediately shift the burden of proof, like they have some type of model in the hopper back here that's correct. We're just waiting for you to present your model so we can present ours. No. I don't know about you guys. Have you ever seen a globe Earth model?
No,
anyway.
they renounced Google quite some time ago as their model.
Well, I got to be honest, John. I'm a little disappointed, mate. I almost want to quote a bit of Monty Python at you. Back to Will. You're not the Messiah. You're a very naughty boy.
Disappointed?
That's
You'll have to
merely a
expand on
flesh
that.
wound.
What do you mean disappointed?
I genuinely, I don't know whether I was just being hopeful. No. I mean, the point you're making is spot on, and I think it's the outside of trying to point out to them what level means in every other walk of life other than in Narnia. I think the geoid implication does have some massive effects on even their wiffle waffle argument. It takes that apart. So it's
What's a geoid?
the flattened ball.
That's a hypothetical shape of the Earth, isn't it?
Yeah. But in doing so, what I mean is, to me, that it kind of that point you make there, which is unusual for you, to beg the question for them, that if it was that squashy ball, that would be the secondary implication, that the sea level is no longer the same distance based on the distance to the center of the Earth.
I just pulled up the definition for geoid. It has the hypothetical shape of the Earth. I can stop right here. Not playing anymore.
Yeah.
Well, express why. Explain the begging the question part of it. Got your
Me or John?
I've got your no, John, please. I've got your screen presented, John.
Say again?
Can you explain why? You don't have to go any further. Just explain. It's begging the question.
Well, it's a hypothetical shape. It's not in reality. A hypothetical deals with it right there. I don't have to concern myself.
Fair enough.
Right? Yep, that's it.
Yeah, so it's a globe, or it's not a globe, but you can think of it as a globe.
Thanks. Yes,
Yeah.
exactly. No, it's not a geoid, but you can think of it as a geoid.
Ah, that's it. Yeah.
Yeah, and as I say, the advanced features of Google Earth enable you to bring up the elevation profile and check that it's actually flat, and that every height lower or higher than others is referencing flat, but then it lets you visualize the nonsense that they tell you it is at the same time, and even show you it curving on their nonsense picture, the line that you've drawn and measured as perfectly flat. Useful, very useful.
Well, yeah, and it matches perfectly with our predictions.
Exactly. We've got Mystic Meg predictions too. Obviously they're not scientific, but they're definitely pseudoscience. So our pseudoscience predictions came true, and there you go. Job done. Right, we do have a link to the Discord server, so if you do want to join the discussion, feel free to click the link in the info box below the video. The Discord server is open for people to discuss anything that we have discussed here. We have got a few people in there already. Hopefully they're all on, or off mute, I should say. Hello, Discord server.
They're all muted.
Nobody's brave. Well, anyway, as I say, we've got a Discord server for anybody.
We got Emerald now. So maybe Emerald will chime in.
Hey, Emerald, can you hear us?
Yeah. Well, let me mute the stream. That's going to get interesting. There we go.
I did have another point, Nathan, which why we're setting up there, but you've kind of answered it. It was, you showed the actual physical measurement. You showed the actual physical measurement. Why you would then plot that?
Sort out your feedback.
Flat data upon a ball, but you did answer it. It's an advanced feature for religious purposes. So
you have to repeat it because there's someone who joined the Discord server with their watch page playing. Can you just repeat that?
I can only be sarcastic once.
Oh no.
No. I genuinely, I did write down what's the purpose of presenting the data, taking the data, which is all flat and level. We've took flat and level, and then why would you then? And most importantly, that the data to plot it upon a ball isn't even matched by visual observation. So I was curious as to why it was plotted like that. But like I said, you did answer it. That it's an advanced feature. Like I said, you did answer it. That it's an advanced feature. Like I said, you did answer it.
People joining who don't have to mute their watch page when they join. Mute your watch page if you're in the Discord server, otherwise you cause crazy audio. Yeah, definitely hijacked for a second time. It's an advanced feature to show the religious faith that people have in a sphere Earth in comparison to the actual measurements versus the flat plane. Correct?
It's a bit like the function of a priest, isn't it? The priest's there to interpret the Bible for you, and they've now interpreted this visually for you from a religious viewpoint.
Yeah. So we've got a whole Discord full of people now. Has anybody got anything they want to ask?
Yeah, can you hear me?
Hey, 10th man, yes, we hear you.
Yeah, good to be back. It would seem like, and I caught the end of this, so I'm going to watch the whole thing again, but I'm familiar with it. It would seem like you need to live in Narnia and have rules of Narnia.
What up, motherfucker?
Yeah, right. So you need to have Narnia and the rules of Narnia to have level mean curve.
Yeah, level means curve if you're a fundamentalist religious zealot who believes you live on a spinning testicle flying through an infinite vacuum of never-ending nothingness that's expanding out into nothingness, derived from an infinitely small substance that exploded out
Right.
into everything. Yeah, you need to believe all that crap. That's correct.
Yeah, so if you live in Narnia, then you can listen to all the pseudoscientists who cannot verify with the scientific method the reality that we live in, because the reality we live in is not Narnia.
No, it's Retardia.
Very good.
So what would this model be accurate for? Would it be accurate for distances, directions, what all?
This model is accurate for its claim predictions. That there is no vertical drop.
Is that the extent?
There is no vertical drop. That's all the extent needs to be. There is no vertical drop over 500 miles and no vertical drop over 1,000 miles. The 500-mile observation, the vertical drop should be approximately 31 miles. For the 1,000-mile measurement, it should be approximately 128 miles of vertical drop. So it's not there. There is no drop. It matches perfectly the definition for level and flat. And matches our
Right, it
predictions
matches those
perfectly.
two predicates. I'm asking, does it match anything else?
Nope. Not that
Okay.
I've looked into just yet. Any further questions?
So, John, are you saying that this is just a model with regards to sea level? A bit like all the ball models are only applicable in one function. There is no overreaching one. So it's just applicable with regards to levels. That's
Yes.
That's what it's a model for.
Yes.
Yes.
Measuring vertical drop. That's all it needs to be.
It is
Looks useful for that.
It's a flat Earth model.
Exactly. Brought to you by our Flat Earth friends over at Google Earth. Hashtag same team.
Thought there'd be more questions
I
from the
don't
Discord
see-
server. Any more on the Discord server?
Yeah, I don't see any difference between this and the NASA documents and government documents and Martin Marietta documents that say all their equations are for a flat surface Earth. It's the same.
Yeah, that's because it's flat.
Exactly. So when they
Amazing.
want to have
Amazing
something in
conclusion.
reality, when they want to have something match reality, it's over a flat surface. When they want to brainwash everybody, it's Narnia world.
Any more questions? Everyone's happy? Everyone's happy to accept this?
Yeah.
Excellent,
Yeah. Well,
outstanding model?
Yeah, if you want a model that will tell you the drop in elevation across 500 and 1,000 miles, then good job. I'm just curious if there's anything more that it can make accurate predictions about, or anything else that it can, anything else that agrees with reality about.
Oh, oh no, we made that clear as well. It's definitely pseudoscience. It's a reification fallacy. We don't live in that model, obviously.
All right.
Yeah.
Any more questions?
The main mission, hold on 1 second. The main mission was to give flat earthers some cowbell. So when they arrive in the debates, within the first 3 seconds, please show us your flat earth model. Here you go. You just pull up Google Earth You can make any measurement. I did it from, these are arbitrary, from coast to coast, take topography out of the equation, and you could do this anywhere on our flat Earth model, right? And then when you're done, you say, okay, let me see your globe Earth model. Let me see it. Can you manipulate it? Can you measure it? Can you show me the drop? Because that's the most important thing, is drop, because of their quintessential religious tenet. Remember, every point along a tangent from their feet drops, that is, vertical drops away from them at 8 inches per mile squared.
And that can be measured.
And it should be measured and confirmed on their model. So that's what we want to see.
And it can be. And it can be measured.
Could a glober not point to that curved line on the surface and then call that the drop?
Which curve are you referring to? The advanced reification facility that allows you to visualize the world that we're comparing it to?
No, measure the curve from a spot in an elevation. Measure the drop.
Maybe, yeah, I understand what you're asking. Sorry, no, I get it. Yeah, maybe that wasn't done properly. If you can just roll the line that you've got that we're going to measure and show it reference to the top. There, you see how that line now curves consistently with the top edge of that curve on this reification fallacy. Can you see that? So now, John, if you can just bring the elevation profile again. This is the bit that maybe wasn't made clear last time. So there we go. You can visualize it. You can think of it as curving. There we have it. If, John, you can just run your mouse again along the bottom edge. There we go. So all of these heights, when showing the seabed, show it referencing against a flat surface. So you can very quickly and easily, with this advanced feature, roll up to compare what they say the curve should be. But then when you use the accurate measuring tool of this elevation profile, it shows that it's all referencing a flat plane.
Tell you what, Nathan, that advanced feature is awesome because even though it's not a curve, it does allow me to think of it and see it as a curve.
That's the mantra we had when discussing this with Google. What we need is something that shows you it accurately measured as flat, but allows you to think of it as a curve while seeing that it is most definitely flat. Very useful.
The last question I have is how do you know whether Google decided to use your definitions for level and elevation, or if they decided to use a geoid for measurement?
Oh, I understand. John, can you bring up the elevation profile again, please?
I'm just curious what Google's source is of that elevation data.
Well, I'll show it you.
Okay.
There you go. It's showing it against a flat surface.
All right, I can see that the data is flat. The question is, what did they source that data from? What are they measuring that elevation relative to? What does Google consider elevation to be within their program?
Well, it's showing
That's what
you.
I'm curious.
It's visually obvious. Can you not see?
I do see it. I see that the data itself appears flat.
Yes,
but I'm curious
that's correct.
where they sourced that data from. Where does Google Earth decide to pull elevation from? Because clearly they haven't just scavenged every square inch of the Earth and measured the elevation. They must get it from somewhere. I'm curious where that is.
You need something big and flat to reference
Right, but
it
do you know
from.
what the source of their data is?
Sorry,
I'm wanting to
I was
confirm
on
this
mute.
information.
Let me say this. Listen, mean sea level.
Ah, the sea's big and flat. You're right. That'd work.
And another thing, let's take a look at this. Let's put this in a comparison with the diagram I showed earlier. Remember, from the top, every point along a tangent from your feet drops. Vertical drops away from you at 8 inches per mile squared. So you see this point at the top of the ball? You see this point down here at the bottom of the ball? You see the tangent should go straight across. There should be drop. Hello. You need me to pull that up for you again? Let's take a look at the other one.
So the thing that confuses me is the way you had it laid out. You had the leftmost point at the top, right? So you'd expect that to be something like 4 feet of elevation. Then
oh my goodness.
I assume you're expecting then that if it were actually a sphere, the rightmost point would be some really low negative number, right? Because it would have dropped some incredible number of miles.
Still presenting, by the way, John.
Yeah, I was interrupted. I mean, he wasn't done, right? He stepped all over me. I wasn't done yet. What's the problem here between these two images? The same thing, right? Right? We're at the top of the ball. There should be vertical drop at 8 inches per mile squared. Correct?
I'm confused.
Correct.
What's,
you see the
I've got to do it again. I'll try and just go back to the Google Earth image. I didn't expect when you know, at first I was like, oh, comical. He's revealed the advanced feature. But now there's so much confusion about this advanced feature. This is just a 3D graphic, right? This isn't the world. This is just a 3D animation of what some fundamentalist religious zealots believe the world is. So that you can picture what it looks like and show this drop that's supposed to be there on this line that has a flat surface referencing the elevation differences. Yeah? It's just a comparison tool. But we don't live on that. That's just a reification fallacy.
See the comparison? Right? At the top of the ball, there's drop. Right? You see these drop values? Well, there is no drop. We just went over it. The elevations are the same, meaning they are level or flat. And you said the different definitions for level and flat? Can you? What do you mean by that? I mean, I just posted 3 sources. I don't even know why I needed to. What level means? Level is flat. Do you need me to bring them up again? Let's bring them up again. I think it's important to go over those. See, let's go over these one more time. Level equals flat. They are mutually inclusive. So these aren't my definitions. I'm not Merriam-Webster or Cambridge or dictionary.com. That's not me. You follow that, right? Level, to make a line or surface horizontal, make flat or level. Synonyms, even, flat, flush, plane. Level, flat, plane, even, smooth means having a surface without bends or curves, right? Making them mutually exclusive, curves and level and flat. You following so far? Dictionary.com, having no part higher than another, having a flat or even surface. Being in a plane parallel to the plane of the horizon, horizontal, horizon, horizontal, for the gentleman the other day. Level, to make level, even or flat. Finally, from Cambridge, level, not rising or falling or higher on one side, but even in all directions. Flat, horizontal. Something that is level with something else is at the same height. We just showed that with points A and B and C and D. Level, to make a surface flat. Are these my definitions? What's the problem here? And it matched our predictions, correct? Whereby validating our flat Earth model. Thank you.
Hey, John, you have reference 1, if I caught this right, which was Sicily, and reference 2 was Libya, correct?
I think that's correct. 500 miles.
Okay. Right.
Sorry, I was on mute. Do we need to wing on over there?
Can do. Let's
No.
bring up
Okay,
the
go ahead.
3D
Go ahead.
amazingness graphics again.
I'll be seeing it for the first time since I came in late, but thank you.
There you go.
There you go.
Okay, so this is the first time I'm seeing this because I came in late, but I'm listening to the dialogue. And I was thinking the words that came out of your mouth before they came out of your mouth, which is sea level. So when you know the properties of water, and I just drove by the Pacific because I was out of town, and I drove a good 40 minutes with the Pacific Ocean on my right side. It's as flat as you can think of it, but no flatter than water in a cup that's on level table surface, because water finds its level. So that water, that blue stuff between the 2 points, reference point A, reference point B, if we're going to believe true science, that water is not curved, it's flat.
That would be correct.
Great. So now show me curved water, then I might entertain a talk about a curved surface. But since you can't show me curved water, then I have to assume through the scientific method, not pseudoscience, that all that blue stuff between reference A, reference B, no matter where you do it, but in this case, Sicily and Libya, is going to behave like water behaves, finding its level, not counting wave height and all that kind of stuff.
Can we just see
Correct?
it once more
I feel
with,
like
with the elevation profile, John?
Somebody was stepping on there. Couldn't hear you. Go ahead again.
Sphere and saying this is the flat Earth model, right? This is
Yeah.
a dream, isn't it?
Can you just show us once more, John, if you can bring it the elevation profile for Sicily to Libya? So it's in a square box referencing flat, not referencing any curve.
0.00 vertical drop. And it matches the definition. Let's go back to point D. Remember our definition of flat and level, right? Not rising or falling or higher on one side, horizontal or flat. Level, something that is level with something else is at the same height. So let's see if these are at the same height. The elevation of point D is 4 feet. Let's go to point C. We'll wing on over to Sicily. Let's see what that elevation is. Remember the 4 feet on point D, right? So the elevation here is, it's kind of small, 4 feet. That matches the definition of level or flat.
Brilliant.
So now they're left with a bigger problem. The in-between of point A and B, which is level, has to have curved water. Show me.
No, we show it as flat. The elevation profile shows it referencing a flat surface. The elevation differences are referencing 0, flat.
Yes, agreed upon, which means the water is level too.
Yeah, well, fluid dynamics would dictate that. I mean, this isn't a demonstration of fluid dynamics, but yes, that would hold true anyway, wouldn't it?
Right, but if I'm going to play devil's advocate and be a glober, then I would say, well, the water in between the 2 points are curved. And I'm going to say, great, show that to me. Show me when water curves.
Do you want some questions from me? I'll role play the dumb globe earther.
I mean, role play.
Give it a try.
Or whatever. I'll be.
So,
ahead,
wait a minute,
Dawn.
who am I playing and who are you playing?
Go ahead, Dawn.
Just got some questions like, obviously, I'm not going to understand the deep reversal of the math. Well, reversal of the reversal of the math is what you're saying, isn't it?
Can you role play Rumpus, please?
No. I just guess, could you explain it in Dawn terms? How this is a flat Earth model when it looks like a sphere? I don't get it.
No, it doesn't. The measurements that it's referencing for the elevations are referencing flat. It's not showing any drop. Now, while you can have the 3D, what did I call it again? The special feature of the animation showing you what the fundamentalists believe is the Earth, you can clearly see in the elevation profile, and if you run your line of your mouse along from point A to point B, or simply measure point A and point B and give you what elevations it shows, there is no elevation change. They're at the same elevation.
Okay. But that's still a globe Earth model, right? Even if you're right.
So
They're
you
lying.
believe that
That's
no
still a model
drop.
of a globe Earth.
So you think that no drop It's a globe Earth model. No, I'll say it again, Dawn. If it was a globe model, the reference for the elevation change would show it on a curve. But it doesn't show that. It shows it referencing a flat plane. And any elevation differences over 500, or in this case 1,000 miles, show no deviation from that flat surface other than the topology itself.
Okay. So do you mean when you zoom in, it looks flat, and the math on the side shows no drop, right?
So right now, there is a box showing the elevation profiles. Now it's obviously a bit water, so in this instance, it's for some reason not actually registering.
That is an interesting point.
I'm trying to talk, Dawn. Yeah, so in this square box with a flat bottom, it would show, if it was to show the sea surface, which it seems to intermittently do, but we'll put that aside, it would show the elevation differences of the seabed versus a flat, level surface. Not a curved surface, a flat surface. So any elevation differences between these 2 points at 1,000 miles are referenced to flat.
I see what you're saying. I'm not the cleverest guy, but I could read some of the points out in chat of people that are disagreeing.
Okay, Dawn.
They're saying
can you see what's on screen? Can you see the live feed? Can you see the live feed?
The elevation change should not show it on a curve, apparently.
Sorry, elevation change should not show on a curve. Wrong. John, can you bring up the depiction again, please, of the... Not this. That's the one. There we go. For the audience, and hopefully Dawn, if he's watching the live stream. Yes, Dawn, if you're on a sphere, you should absolutely unequivocally see drop. That's what a sphere is, mate.
What do you mean see drop? Me personally see drop.
It's on screen right now. The amount of drop that you should see and measure. So do you concede Dawn, that not only should you see drop, here are the exact measurements for how much there should be? Do you understand that there should be drop?
Yeah, I'm reading the other guys'
Just to answer yes or no, given that there is a mathematical table of how much drop there should be on screen, do you concede that there definitely should be drop on your sphere reification?
No, I don't care about these math things.
They're from your side, Don. They're from your side, and you're parroting someone in chat instead of using your brain.
Just answer my question, Dawn. I'll say it again. It's on screen.
You raised a point.
Just answer my question, yes or no, Dawn. Given that it is on screen, the amount of drop that there should be on your sphere Earth, do you, given that it's on screen, concede that there should be drop?
You mean, do I think there should be a number there that explains the drop from that curve?
Should there be drop? Given that it's on screen showing the measurements of how much there should be. Should there be drop? Just say, yeah, on a sphere, there should be drop.
Well, obviously spheres are curved, so yeah, if you're measuring a straight line out, there'll be drop, yeah.
Oh, so there should be drop. Right, John, can you go back to Google Earth, please? Right, Dawn, do you see this box? It ain't curved, it's flat. These are supposed to be highly accurate measurements of topology differences, and they're referencing a flat plane.
I think it's someone else's go. You've raised the point that they don't show the elevation like you want them to. So,
Nathan,
no, I don't think it's a big deal. I think it's silly.
Do you think that it's the fact that it's referencing flat isn't a big deal when it should be exponential? There should be a squared function of drop
that shows our planet, and you're saying this is a flat Earth model.
Yeah,
to me,
that's flat. Did you not understand that it's showing a flat?
You're pointing at a sphere and saying, "Look, there's no drop."
Yeah.
Don, when you're looking at a side
point, I know how it happened, how the point was invented. I know this backstory, but it's just silly to me. It doesn't look like Earth pizza.
Don, this is from your side. You're looking at a sideways angle of your globe.
Yeah, I think this point kind of goes past my level.
No, just think for yourself. Does water curve? And if it does, then we would see a curve instead of a level line from point A to point B.
You
You're
mean
not
on Google
thinking.
Earth? You mean on Google Earth?
No, I'm saying Google Earth shows A and B at 4 feet at both ends. Well, if they're 4 feet at both ends, what's in between? If we're on the ball, there should be a curve in between. But they're side angle.
Hang on, both points say 4 feet.
Yeah.
What, can I finish? The side angle of that view from the top, the one that shows point A, point B with the blue, the picture, that's the top.
Curved red line over the curved ocean picture.
Don,
That's
can
right.
I finish?
Yeah.
Point A, point B, with the blue in the middle is the ocean, is looking down from the top of the globe. Then when he pulls up the side angle, it's that box. It's that box. And Google Earth, which is not a flat Earth company, says there is no drop between point A and point B.
I think you might be getting confused with elevation and drop, honestly. That's about my understanding.
Elevation and drop is getting confused. Is there another drop besides a drop in
you're
elevation?
Not getting confused, obviously. What I mean is you're lying about elevation and drop. That's what I actually mean.
Oh,
no worries.
we're lying.
Hold on, no worries,
Drop.
Dawn. That accusation won't go unfounded, unaddressed. Can you just bring up your definitions again, John? Clearly, even in the face of these things being on screen, like we saying, is there supposed to be drop? There it is on screen. Won't concede that there's supposed to be drop on their model. Amazing how these globe heads fight tooth and nail to tell us how much drop there is usually. Suddenly, they're not wanting to tell us about drop anymore, it seems. Amazing. Nevertheless, John, can you bring up your definitions and we'll have a little look about level.
Do I need to read these again?
I think so. He's accusing you of lying about the definition.
Or do we need to go to drop?
Drop. Yeah, drop.
I think we might need to go to drop. All right, let's define drop. From dictionary.com, drop, to fall vertically. Have an abrupt descent. Drop, from Oxford, drop, letter makes something fall vertically. Height, altitude, elevation mean vertical distance. You can only have drop in the vertical. You can't have drop in the horizontal. Follow?
I know the definitions are behind you guys. I know. I'm saying you're mixing them up and confusing people.
It was on screen. It's come from dictionary.com. What's the problem?
Oh my God. Elevation is above the surface of the earth. Drop is the curvature. There's two different subjects we're talking about here.
With that in mind, if John's got a minute, I'd like to test his model.
Yeah. Throw what you can at it.
All right. John,
did we just do that?
Oh no, I've got
go
a
through... Oh my God.
I've got a much more stringent one for you, pal. And hopefully it might exemplify the point with what he was making in the presentation as well, because I think people are not quite getting it. So I just wondered, John, if you could maybe check the sea level for me at the North Pole.
Which North Pole? Magnetic North? Or
Anywhere close. I'm not finicky, mate. You know, just anywhere up around there. If you just check what that sea level is, because we're working this on.
You want me to check what sea level is? Sea level is level.
So shall we call it 0 then?
Yeah, it's kind of level
I'm happy
because
with that.
it's
So
sea level.
let's go to the sea at the equator then.
Let's see where we got here. Where is Columbia? So right around here.
Yeah.
Yeah, the sea everywhere is level.
So that'll be 0 as well then.
Yeah,
So I'm
because
just gonna write those numbers down.
Because it's sea level.
Yeah. Well, that's what I thought. So I was just trying to compare the data you've got as to whether it's a flat Earth model that the data fits, or whether it's a ball Earth model that the data fits, not what the image is on the top. So while you were talking earlier, I had a quick little look at the geoid model that they're talking about, and it's quite interesting. When Neil deGrasse Tyson talks about it virtually being a perfect sphere, he's actually correct, because it's less than 1/3% the difference between the maximum and minimal radius. But that's quite significant, because that's how they define mean sea level, is the distance from the center of the Earth to there. So actually, between those two figures, there's a 13-mile difference on the ball model between if you were measuring it as a distance to the center of the Earth. But they appear to be the same, both at 0. But the one at the North Pole should either be -13, or the one at the equator should be +13. Or somewhere at 45 degrees 0, and them two be 6.5.
Whoever said that elevation is measured from the center of the Earth is kind of wrong. We already went over that.
Well, that's what I was just saying now. I just wanted to check it in terms of what the flat Earth model you've got, the data it presents, and it confirms it's a flat Earth model, and it doesn't fit the data that a ball Earth would require.
Right? An ellipsoid.
Yeah. So there's not that 13-mile difference at sea level between the sea level and the center of the Earth based on the ellipsoid shape. It's only less than 1/3%, if you want to quote statistics, but it is 13 miles. So one of them should be 13 miles more or less than the other at sea level, if the data was representative of a ball model.
Are you trying this game?
Yeah. I was just checking the data, and the data is clearly flat.
Yeah, they have a big problem, right? You can't. The elevation can't be, because it's a rubber ruler. It's a rubber shape-shifting ruler. Can't be a benchmark, because everyone's changing, right? So it's nonsense.
Cool.
So who's the guy that said elevation and drop are different?
No one wants to take the responsibility, it would seem, 10th man.
Well, let me go on then. If I'm standing on level ground, which on my property there's plenty of places, and something is rising above me, say a hill, and I have some olive trees on it, and I could visually see it's rising above my level ground I'm standing on. And right next to that, I have a little causeway where when it rains, all the rainfall goes down, and that is dropping from where my level ground, where my feet are. So in one sense, I'm standing on level ground, and I could see it's level. I can even put a level on it, and it's going to be pretty level. And then to the left, I see the drain or the ditch, and that's obviously visually dropping from my position. And to my right, I got the hill with the olive trees, and that's obviously rising from my position. So we got point A, point B, Sicily and Libya, at 4 feet. Now, in between, if it's a curve, it ought to be measured and seen. The properties of water, the properties of water, finding its level, That's one thing the globers have to overcome. The other thing, hang on, the other thing, you'll get your chance. And the other thing is not only should you visually see it, then, well, I'm sorry, that was the other thing. You should be able to visually see the rise, since you're at this point on the ball, and away from you it's dropping. You should be able to see that, but we don't see that. And when John put the 8 inches per mile square, the number for the circumference of the Earth worked out by the globers themselves, you can't even see it over 5 miles, let alone 10 miles, let alone from Sicily to Libya. Back to you.
Coolio. I can see Zanuck flashing, but I can't hear anything from him. I don't know if you can.
Say that again?
That's Zanuck. This is Zanuck. It's flashing, but I can't hear anything coming out. Anyway, any more in the Discord server?
I think we're off kilter here. Someone's not hearing somebody.
Not to worry.
Well, what I'm looking for, if I heard it right, is for a ball to behave like a ball and the shape of a ball to show the shape of a ball. That's what I'm looking for.
Aren't we all?
No, we have your measurement. It's 8 inches per mile square. And through all the testing we've done, we can't measure it. So, sorry. Well, please offer that test. What is it?
Okay, yeah, there's definitely somebody that's speaking that you can hear that I can't. That's weird.
Hang on.
Hold on. Nathan, did you have Zanuck unmuted or muted on by yourself?
I can see.
They can't hear us talking.
No,
right click on Zanuck, and because you might be muted. You might be muted again.
Not in my end. He's unmuted, but I can't hear him for some reason. Weird. Anywho, right, anybody on the Ballbusters panel that wants to round out? If not, I don't think we've got anything else from the Discord server, and I can't hear Zanuck.
No, they don't have you blocked. He's not getting you. So call on tomorrow's show, and let's continue this conversation.
Hang up, and come back.
I got questions.
You got more questions?
Hang up and call back.
No worries. Go ahead, Dawn.
Yes. The scale at the bottom that was showing no elevation when you were scrolling across the line of the ocean. Is that sea level, that scale at the bottom? So it's showing the same sea level all the way across?
No, the reference, the box itself, the entire box is square and well, it's not square, it's rectangular, but flat.
Yeah.
The reference to
but
any
is that showing sea level that?
No, it's showing any topology.
So the elevation all the way along, right? From sea level.
Well, what's under the water could have a topography like.
Obviously, it's not going to show a curve, is it? Because it's sea level all the way along.
Well, yeah, that would be our argument, Dawn.
That's not an argument. That's what the scale is for on Google Earth. That's what it's showing.
You're showing it's flat.
I've been updated, and apparently, on purpose, you're confusing sea level with elevation or with drop. I mean, sea level with drop. It
doesn't show any drop. Over 1,000-mile expanse, it comes out in a square. I keep saying square. In a rectangular
that's
box.
Not supposed to show drop. That's the sea level.
I'm in the middle of a
meter,
statement,
apparently.
Dawn. Yeah.
It's a sea level meter. So
Dawn, I heard your assertion twice. Yeah, so every time it presents it, the reference that it gives is flat. That box has got a flat bottom.
So because the box,
Dawn, I'm still in. I'm going to kick you out, Dawn.
That's what you're.
Yeah, Dawn. I'm going to kick you out, right? Because you're being an asshole. I'm in the middle of a statement, and you start talking, asshole. Yeah, the box it presents it in isn't showing it referencing a curved surface. It's showing that any difference in topology is being referenced to a flat plane. That's why it's in a rectangular box, got it right, with a flat bottom. Not curving. Not demonstrating drop. Demonstrating flat.
So would you be happier if there was like a curve on the bottom and a little dot went over the curve?
What you mean if
they
it
did that?
demonstrated drop? Would I be happy if it demonstrated drop?
Well, yeah. Would you like a curved graph instead of a flat graph?
Let's not concern ourselves with how our pseudoscience predictions come to pass. They do. It's flat.
You're saying this sea level graph that shows the same sea level all the way along means the Earth is flat.
No, the box, it's referencing... You're dumb or deaf, one or the other. How many times have I got to repeat it?
Could you zoom in and show me where it says a drop meter or something like that on that
Do you know what a
graph?
drop
'Cause I haven't
is?
looked at it myself.
A drop means it's dropping. Going vertically.
You zoom in and show me that where it says drop on that scale.
We gave you the definition multiple times in this show.
No,
in
on
the
the
stream,
scale,
we've
the
defined,
scale,
and now
that's what
I'm
you're
talking
saying.
and you're talking over me. Yeah, the definition of drop has been made absolutely crystal clear with definitions, cited, with little links next to them. Not made up by us. Yeah? Okay, Dawn? Drop, meaning going vertically. Like the diagram that was on screen while we were getting you to concede that it should drop. Now you're saying, well, the drop's not there. Would you be happy if it showed drop? No, Dawn, it's not showing drop. If, who cares about this if that you've invented? That's not what's been demonstrated. Have you finally understood that it isn't showing drop?
What do they name that scale at the bottom? What do they call it? On Google
I
Earth?
call it a flat line. What do you want to call it?
No,
Something
what
else?
do Google Earth call it?
I'm
That's
answering
what
you,
we're talking
Dawn.
about, right?
I'm answering you, stupid dick. That means shut up.
You said what you
Don't
call it.
let
I
me
didn't
get
ask
4 words out, then keep talking, right? What
You
is your
answered a
malfunction?
different
What is this
question.
baller's problem? Yeah, is it finally sunk in that the line that it's referencing is not curved, not showing drop, Dawn? Has that sunk in yet? Because a minute ago, it was a struggle to get you to concede that there should be drop. Hello, dumb fuck? Do
is it
you
labelled,
understand
Nathan?
now that
You
it
haven't
doesn't show drop?
What is it labelled though? Because I haven't personally looked.
It's a flat line. What part of this aren't you comprehending? It's a flat...
So flat graph means flat Earth. That's what you're saying, right?
Yeah, Dawn. No drop. Is that sunk in yet? It is very simple. Unbelievably so. Hello? Has it sunk in yet that flat
No,
line
mate.
isn't
It's getting
showing
weirder and weirder
drop?
every day. Hasn't sunk in at all.
Well, then you are
Getting weirder and
retarded.
every time you come out with a new little idea, it's more and more fucked up.
Still haven't answered my question. The box with the flat line along the bottom, Dawn. Do you now understand how that does not show?
Well, I look it up myself.
Why is it every time I
Label.
come to ask the question,
What are
he
you gonna
interrupts
tell
me? What is his malfunction, right? Every time I ask him a simplistic question, I get to the conclusion of the question, the critical bit. The most important bit is when he talks. Yeah, you fundy zealots. You don't have to like it. Yeah? That is not demonstrating drop. It's demonstrating Earth is flat. Now, you can tell us there shouldn't be drop. Given that there should be, that's a massive problem for you fundies who think there should be drop. Because there isn't. So I'll ask Dawn again. Do you recognise, Dawn, that a flat, level box is not showing drop?
Yes.
Excellent. Finally, the fundies get it. The fundamentalist religious zealot understands the most simple and eloquent demonstration of the pseudoscience magnificence that is the flat earth Google model. Yes, it shows that it's referencing flat. It doesn't show drop, even though we can bring up the mathematics of precisely how much drop there isn't. Right, Dawn?
I don't think it's supposed to show drop, is it? It's a sea level meter.
Yeah, Dawn, it's supposed to be showing drop. You think you live on a sphere that has drop? We showed you the maths. You were very hesitant to concede. It's amazing. This is the first time in flat earth debate history that we have a situation where the globers are telling us there shouldn't be drop.
Psychopath weirdo.
Shouldn't be drop, you're saying.
Can I ask Don a question?
What do you expect? Do you expect the elevation to drop?
My fucking mind next.
Let me get it right. I'm now being asked by fundamentalist religious zealots who believe the earth is a sphere if I would expect to see drop. We had the maths up for how much drop there should be. Are you guys retarded? Yeah, if you believe you live on a spinning sphere flying through a vacuum, then yeah, you should damn well expect to see some drop. The problem is, there isn't any.
It's not a drop meter, Nathan.
Drop meter?
Elevation isn't an Earth drop meter.
Don, can you define level for me,
Maybe
please?
you could use the drop curve calculator instead. Maybe that might be more helpful.
Yes, we did, Dawn. We had it up on screen for you and showed you precisely how much drop it's not showing. Lots of drop. Lots and lots of drop that's not there. Just a measurably flat plane. Referencing a flat, rectangular box that doesn't show any curve.
Not supposed to, dude.
It's a sphere. So we've got round and round in circles. It's a sphere and should have drop. That's what Soundly's measuring, right, Dawn? He's measuring the amount of drop that he can see. Remember, Dawn, Soundly, with his drop? Yeah? All those people that say stuff's dropped behind Earth curve? The drop in the Earth curve calculations? Yeah, Dawn, yeah. That's the drop we're talking about. The drop that ain't there.
To show a drop on the spherical Earth.
Maybe in a couple of weeks you'll turn it on and the bottom little line will be curved.
Maybe.
And you'll be like, woo!
Good job we dedicated this to a recording and live stream, eh, Dawn? With you, the fuckwit fundy, going, I don't think we should see drop. Oh, really? What are these drop mathematics that we've got here showing precisely how much drop we should see? You don't think there should be drop? Amazing that ballers are telling us that we shouldn't see drop. Isn't that a shock?
Yes.
Don, you got a big problem. Don, you got a big problem because you got water on top of that supposed underneath that you say is curved.
Hey, can you hear me, Nathan?
It probably hasn't dawned on him.
We do, whoever that was.
Hey, I'm just wondering if the Google Earth or Google Maps is accurate, when can we expect to see the continents mapped out on a flat surface, seeing as we now know the distances between land masses?
I can't speak for our corporate sponsor, Google. You'd have to contact them.
Bro, you have it. Just zoom in on the Google Maps. All maps that you see on Google, you are looking at on a flat screen. So you just take that flat map that you are looking at on a flat screen and you transpose it onto the flat Earth that we live on. There's your flat continental maps. When you look at Google Maps and it shows the ball all zoomed out, that's not accurate. It's only when you zoom in and see a flat topography that you get any accuracy. So yes, if you want to see flat maps, look at all maps.
I don't think distance was John's claim for the specifics of his model.
No, it's the flat Earth model. I thought we made that clear in the title.
I think there's some confusion still now.
I don't know. I thought that was self-explanatory.
No.
It's demonstrating
I'd still
a
like
flat
Don to
Earth.
define level for me.
Flat.
Perpendicular to the plumb line, tangent to a curve, level. You
can't have a level curve.
Sorry, John.
They're mutually
If you build
exclusive
a-
terms.
Sorry,
Married
John, can you-
bachelors are more coherent.
You're right. You can't have a level curve, but you can have a curve and you can have something level on top of the curve.
Okay, no worries. John, can you bring up our flat Earth model, please? And show us the elevation
Let's
profile.
talk about how you can
Excuse
actually
me,
show
I'm trying
the
to
curve,
address
the
your
drop.
point,
You
sir.
want to talk about the
I'm
drop?
trying to address
You
your
have to use
point.
Google-
I'm trying to address your
Pardon
point.
me?
You said that it was parallel with a curve, correct?
Okay, well, Google has elevation.
You just
versus
need an
curve. Which one do you
affirmation
want
that
to
that's
look
what
at?
you're claiming. Yes,
can be
Nathan,
level
that's
or
what I
be a
said.
tangent to a
I'm
curve.
just repeating it. Yeah, don't need it. You won't do it. You're an asshole. Yes, that's what you're saying. It's
See how you're mixing them up and he's having to ask you which one
Excuse
you
me,
mean?
I've asked him to repeat something. It's not like I'm asking for him to suck my dick. I'm asking him to
Tell
repeat
him-
what he said. So he's not going to because he's an asshole. That's what I've said. So let's make it clear. This box that's about to be drawn up is not showing stuff going alongside parallel with the curve, is it?
It is, depending on whether or not.
Sorry,
Google
no,
decided
it's
to use
not.
that
That's
to source
visually
their
bloody
elevation.
obvious. You are a moron. It's not going parallel with a curve, is it?
Is the elevation?
Depends on if Google
Excuse
decided to
me,
source
are
it
we
based on
dealing
data.
with people who are blind? This is not curving. Hello? Are you blind?
All right. Now,
I
do you
want
know
the guy who
difference
said
between
that it runs
elevation
parallel with
and
a curve to answer me. Only the guy who claimed it was parallel with a curve. Here are the elevation profiles. It ain't running parallel with a curve, mate.
It is parallel with the curve, yes.
No, it's not. You are a moron. You are blind. No, it is not. That is visually obvious to anybody with eyeballs. There it is on screen, you moron. Are you literally blind?
Look, Nathan, if I take a measurement,
No, you don't get it.
Linear.
Not if you take a measurement, you stupid fundy. We're showing our flat Earth model, how it shows it measured, and it's showing it flat. Let's not worry about you and your stupid fundy measurements.
Nathan,
You can measure
These
drop.
measurements don't run parallel with a curve, which is what you claimed. It doesn't show that. That's precisely the point. How many bloody times? Dawn had to be dragged by his short hairs around this. Why are you having to be dragged around by the short
I can show
hairs?
you a curve.
It
Wanna see-
ain't parallel to a curve. It's flat. Can you not see?
Parallel
Look.
to a curve.
Yeah, it isn't. Look,
Look,
I'll
Nathan,
run my
if I
mouse
take a
along
measurement
just
of
how
the
bloody
radius
flat
of the
it is.
circle around that
Not
circle,
curving.
Design parallel.
Equal radiuses to the curve.
That's not what it's
If I were
showing.
to-
Are you deaf? Are you blind? Are you stupid? That is very fundamentally the antithesis of what is being shown.
Flat.
You are describing the antithesis of what is on screen.
Okay, are the elevations different at two different points?
No, that's been shown. That's what our model proved in its prediction. Aren't you paying attention, fundies? We showed you this multiple times. They are the same level. Here we go with the 3D graphics and the animation of the flat plane that we dwell atop. It's amazing. You can check it out at Google Earth, the flat Earth model.
Look,
Point
Nathan,
A
if I take the
is-
radius of a circle,
Excuse me. Point A is 3 feet. Let's go to point B. 1,000 miles away, there should be 128 miles of drop, vertical drop. The elevation is 3 feet.
Stop talking. You can debate. You
According
can call me all the names
to
you
the
want.
definition
Why
of
is
level,
this guy interrupting?
excuse me, I'm not done yet. According to the definition of level, not rising or falling or higher on one side, horizontal or flat. Something that is level with something else is at the same height. Point B and point A are at the same height, ergo, they are flat, level.
John,
Height
can you
above
just
the surface.
show me those figures again, please? Point A and point B. What are they both?
Just want to show off the amazing flat Earth 3D animation.
It's a little religious, but you know, iconography is something you got to put up with. So, what is it at point A?
Point A is 3 feet. Can you see the elevation down in the right-hand corner of my
Yes,
screen down here?
Yes, the screen.
Yeah,
is
yeah,
presented right.
got you. And then
So-
point B.
Three feet.
Mr. Quantum Eraser, you have one hell of an accurate flat Earth model there, my friend.
Thank you, sir.
Congratulations.
Yeah, courtesy of Google. Thank you very much indeed for the flat Earth model.
You want to see drop? I'll show you drop. A 5,000-foot elevation, 50 miles away from the shore, should be a 0.9 degree drop. However, we measure 1.7 degrees. That is curvature. Go ahead. Just prove that.
Okay, no worries. Do you want to bring up the elevation profile, John? Let's just disprove that immediately with the flat Earth model. Unlucky. it seems to be referencing flat, no drop, zero, nada, none. There's no drop there, my friend. You were wrong. Our predictions seem to be panning out for a flat Earth. Shout out to JQ for the super chat. Really appreciate your support. Thank you very much indeed.
I could measure the bumpiness around a circle, and if it's smooth, it'll appear to be zero everywhere. Just because the data appears flat doesn't mean that what it was sourced from is also flat. That's the issue.
Could we do the line over the land and see if the line wiggles?
You might want to take that issue up with Google.
So I want to see if the line
Right,
moves.
that's why I was asking. That's why I was asking.
If the data is wrong, you might want to take that up with that.
There's obviously a lot of things that people want to discuss about this now. I'm going to give you the link. I know you're all very excited and very keen about this flat Earth model, so I'm going to tell you where to go and get it. You can go and get the flat Earth model from Google Earth.com. That's the site that you need to go and check it out. Feel free to argue amongst yourselves about just how beautiful it proves the Earth is flat. Thank you very much indeed. Is there any last words from the Ballbusters? And then we'll round out if there's not.
This Google Earth you speak of, can you get a paid version for a more religious experience?
Correct. It's called Google Earth Pro.
Awesome.
For a small fee, you can get even more advanced flat Earth features. Anything else?
No, thanks, guys.
Paula, Betty, anything?
No, the same thing we've been saying the whole time, that it begs the question to define level as parallel to the surface of a ball. That's the whole sticking point. It's what Force the Line would have proved if they didn't take Brian Mullen out, who was the engineer who would have built the thing to the degree of accuracy necessary, and it would compare whether these two lines were going to diverge or meet, depending on which one you have on top, because it would have shown whether level means parallel to the surface of a ball or 90 degrees to a vertical line. That would have settled it. But now we get these, self-contradictory Google Earth things that say, show you a curved line, but measure it as flat. And that's where we are.
Yeah, completely agree. That's why it makes such a great flat Earth model. And I will add at the end myself that this might have seemed tongue-in-cheek in reference to curvy Earths and advanced features, but we are dead serious. Not joking. It's showing it's flat. Anyone else from the Ballbusters side?
Nope. Very clear.
Do you want the last word?
Level is not curve. Marriage bachelors are more tenable. Now, for the flat earthers out there, like I said, as soon as you enter these debates, you're going to be challenged to show your flat earth model. See our flat friends at Google Earth. #same team. Thank you.
Adam, any more for any more? Although I just said that was the last word to John. Slick. And with that, I will say a huge, massive, enormous thank you to, first and foremost, all of the Discord server for making this interactive part of the Ballbusters show possible. And of course, a massive thank you to Adam, or the Adam Meakin, Betty Van Velsen, Paula, otherwise known as Knowledge Scavenger, and John Quantum Eraser for making this Ballbusters possible. Be sure to like, comment, share, subscribe, and check out the NathanOakley.com Flat Earth Debate Forum. I've been Nathan Oakley, and I'll see you all in the next Ballbusters.